Our next speaker, Mark Boslough, is a physicist. He is a graduate of Caltech. He's based out of Sandia Labs, so I think this is really a personal presentation, not in his official capacity as a Sandian. But in his work at Sandia, which is where I've kind of known him, works very much on a variety of problems that are relative to sort of catastrophic things that can happen to us. And this is within that range of possibilities to look at.
Thanks, John. Yeah, I'm gonna, okay. There we go, perfect. So thank you, John. It's great to be here. People have asked me, well, why is a physicist talking about climate change? And a lot of people, even a lot of geologists and climatologists don't know this, but climate change was really predicted. Global warming was discovered and predicted by physicists. We'll go into that a little bit. Some physicists here. So I work at Sandia Labs. Normally when I give presentations, I stick to the technical issues. This is more of a free forum. I may end up giving opinions about policies. As Dave pointed out, the science informs the policy, but that doesn't mean scientists can't have opinions about what the policy should be. So I want to start off by sort of proposing a game. You can play a game by shooting a gun into the air. It's not a good idea. And people do that on New Year's, and every once in a while a bullet comes down and injures or kills someone. And so, 6 bullets in the chamber, well, you're going to fire a bullet, it's going to come down somewhere. So we know for certain that a bullet comes out. We don't know what's going to happen, but we know something bad can happen. So to extend the game, you could point the gun at your foot, and if there's only 4 bullets in 6 chambers, well, you're not guaranteed to shoot your foot. There's a possibility that you could. And to extend it even further, would you play this game? It's not a game I would play, but in a sense, it illustrates uncertainty, and it wouldn't be a good argument to say, it's okay to put a gun against your head because you're not certain the bullet is going to come out of it. And so a lot of risk assessment, and the kind of risk assessment that people at Sandia do associated with nuclear weapons, associated with asteroid impact, is all based on assessing risk based on uncertainty. So this is similar to the game we're playing. We're all willing or unwilling participants, but we can't necessarily rule out catastrophe. We've already seen inconvenient weather. A lot of the weather we've seen around the U.S. and around the world, a lot of climatologists are associating with global warming. It's certainly consistent with global warming. It's consistent with the forecasts, but global catastrophe hasn't been ruled out. So we can actually make kind of a graph of this, where probability is represented by number of bullets in the chamber, and consequences are illustrated by the green bars. So as probability goes down, consequences go up. And so, the question you can ask yourself, would you trade a low probability, high consequence event for a high probability, low consequence event? So if you had your choice of which game to play, would you trade shooting your foot with half the chambers full for shooting yourself in the head with 1 bullet in the chamber? I mean, that's not a pleasant thing to think about, but we think about those trade-offs all the time. And so in reality, we're playing all these games simultaneously. So we can actually make a graph. And this graph is really, it's slightly different than this exceedance probability, which is defined by the blue bars. It's a specific probability density function. And so basically it's kind of the equivalent of a plot of, what's the probability of a specific thing happening. And so what I plotted along the bottom is the increase in global mean surface temperature if you double CO2, and there's a lot of uncertainty associated with that. What this does is it represents the uncertainty, but what you can see is at zero, the probability is zero. So it's absolutely certain, nobody really questions the fact that if you doubled CO2, you'd get at least 1.5 degrees of warming. But the most likely, the best estimate, which is what that BE stands for, is more like somewhere between 2 and 3. Some people think it's significantly higher than that. But what's frightening to me is if you go up to 7, 8, or 9 degrees, it's still above zero. The probability is not zero. And it's really hard for me to imagine a world that has a global surface temperature above that. It would be an entirely different planet. We cannot guarantee a zero probability. And by the way, these are degrees Celsius, not Fahrenheit. So one of the things we talk about is denial and alarmism. Those aspersions are thrown by different people with different opinions. And I'm going to define both of those and dismiss both of those. So basically, those are people with zero uncertainty. All scientists have a degree of uncertainty about what the degree of global warming will be. So deniers say basically global warming is a hoax. There's no way that humans can change climate. Whereas alarmists say, well, let's guarantee global catastrophe. But there's an entire range of opinion in between those extremes, and that is where the scientific debate takes place. So going through, and this is probably the most technical slide that I have. So if you look at the upper left-hand graph, I've got that same kind of probability density function. That's what's shown in black. And then if you think about graphing the risk, going from very little risk, and as you have more and more temperature increase, there's more likelihood that it will affect agriculture, sea level will rise, there will be water shortage, severe weather events, and at some point there's a threshold of global catastrophe. We don't know where that is. That's represented by the upper right hand. And this idea of a global catastrophe affected by climate change isn't a modern new idea. I mean, we've talked about that. In my background, one of the things I've studied is asteroid and comet impacts, and that is a basic idea associated with asteroid or comet impacts. If you have a large comet hit the Earth, it's not the comet that would do the damage, it's the climate change associated with the comet, and our risk assessment has always included the concept of global catastrophe without controversy. If you multiply the red curve on the upper left, the red curve by the black curve, you get the blue curve, and if you take the area under that, that's the net risk associated with climate change. And you can see that the risk is dominated by the higher end. And unless we can eliminate the possibility of high-end climate change, we can't eliminate the risk. So this is from a recent publication. This is actually a compilation of a number of different groups' idea of what that probability density function looks like. And you can see, there's a huge range. There's a huge range in best estimate, ranging from between 1 and 2 degrees up to 4 to 5 degrees. But what's scary, again, is looking off at that tail, that high sensitivity tail way over there to the right. None of them go to zero. Nobody can say there's no chance of global catastrophe. So I want to go back to the physicists. So Joseph Fourier was a French physicist. Every physicist and mathematician knows his name. He was also a mathematician. And in 1824, he wrote this publication and basically explained why the Earth is warmer than it would be without an atmosphere. It's because of the insulating effects of the atmosphere. And John Tyndall, who was also a physicist in 1859, actually did measurements and showed that carbon dioxide absorbs heat radiation, and amplified on Fourier's original idea. Now I actually downloaded these pictures today. you can buy these rare books. I mean, you can prove to yourself that Al Gore didn't invent this idea. This was, a 19th century idea that a couple of the top physicists of the century came up with. So then in 1896, another physicist, also a chemist, from Sweden, actually went into more detail and calculated how much temperature might rise if you doubled CO2. Now, this was a time when the light bulb and the automobile were just being invented. He had no anticipation that we'd be producing so much CO2, within 100 years. He was thinking 2,000 to 3,000 years, maybe the Earth would increase its temperature perceptibly. And I've plotted now, what I'm plotting here, and this is in degrees Fahrenheit. This is the NASA. Dave showed several time series of temperature. This is the NASA time series, which starts in 1880. So basically, it's a global average. This is about when good temperature measurements started being made. Arrhenius probably didn't have all this data, but he, had some sense for what the temperature of the globe was doing. And he was predicting, based on increased CO2, that the Earth was going to warm. So at that time, I started at 0. So anything that's cooler than 1880 is blue. Anything that's warmer than 1880 is, it's kind of pink on mine. I don't know what color this is. Okay, so now let's fast forward to 1955. This is a Canadian physicist, Gilbert Klass. He was doing research on the heat absorption properties of the atmosphere because he was looking at heat-seeking missiles. He was basically designing heat-seeking missiles, and that's the physical basis for that. Now you can see that we're in the warm region here, but it's not steadily warming. It's warming in fits and starts for reasons that Dave discussed. But he actually wrote a paper in 1955, and he was interviewed. I mean, this was not controversial in those days. I listened to an interview that was recently discovered by him. It was a General Electric kind of newsreel radio show, and he predicted 2 degrees Fahrenheit per year. So I actually cast that into a prediction for the temperature in 2012, next year. So that's what he would have predicted the global mean surface temperature would be next year, more than a quarter of a century in advance. So let's see how he did. In the meantime, 20 years later, things didn't look like they were warming much. Another scientist, Wally Broker, now this is our first non-physicist, he's a geochemist, but that is a physical science. Wally Broker actually coined the term global warming. And if you listen to Rush Limbaugh and Beck and those guys, they say, well, it used to be global warming, but they changed it to climate change because that sounds less scary or whatever. They're backpedaling. But in fact, if you notice the title of Gilbert Klass's paper, he used climatic change. And so Broker was the first one to use the term global warming after climatic change had been used for many years. And so he made specific predictions based on not by year, but by when the atmosphere has so much CO2 in it, this is how much it should warm. And so I turned that into a prediction for 2012. So that's where Broker would have put his 2012 dot. And he's actually got a plot in the lower right-hand corner, and you can see that he's basically thinking in terms of cycles, but with human-caused global warming superimposed on that. And so he was predicting at a time when there hadn't been a lot of evidence for warming. He was predicting it was going to turn around and take off, and that was a pretty bold prediction at the time. And it's worth noting that it's not just a steady increase. It's not a line like I've drawn, but it's actually an upward curve. It's accelerating upward. Now, I put this on here as well. So I have had this plot of climate sensitivity, this curve with the tail on it. There's another scientist by the name of Richard Lindzen, an MIT meteorologist, and he has written papers suggesting a very low sensitivity. Now, he didn't make this prediction, but if Wally Broker had used his sensitivity, this would be the prediction that Wally would have made. So still net warming since 1880, but no, he basically, Wally Broker would have said the warming we've seen will stay. It won't cycle back into a cooler phase, but it won't accelerate like his graph in the lower right-hand corner. Jill Charney, meteorologist, chaired a National Academy of Sciences panel and basically said that their conclusion was completely consistent with what Wally Broker said. Their conclusion was that the climate sensitivity was between 1.5 and 4.5 degrees C. A large uncertainty, but no uncertainty about the fact that it was real and it was positive. Okay, now we're getting into modern times. Now James Hansen, after the signal of global warming started continuing again in the 1980s, he made very specific predictions. By the way, I looked up his degree. He's thought of as a climatologist, but his PhD is in physics. And here's a very specific prediction he made. He actually ran general circulation models, computer models. Now this is the first one that was really based on computer models. The Charney report included those, Broker didn't. So we've gone from sort of physical reasoning to actual running computer models. But the models are based on solving the equations of physics, solving the radiative transport equations, and so forth. And so he plotted scenarios. So these aren't specific predictions, they're conditional predictions, and for 3 particular scenarios. And I know that graph is hard to read. This one, if you actually take the center one and plot it for 2012, it plots off the top of the page, so I didn't actually plot his. So let's see how they did. So, really, these global warming predictions, when you think of them in the context of the time, they were pretty bold. And science is all about prediction. If you can make a prediction of something before it happens, and then it happens, it very much cements, it doesn't prove that you're right, but it certainly cements your credibility. So let's see what happens here. So I've got the years in the upper left, and we get up to 1998. Boom. That was an El Nino year. That was when the tropical Pacific Ocean was very warm. And then it dropped back, but will it continue to go up? It looks like it's catching up. Oh, no, it's going down again. Oh, so in 2006, it actually dropped below 1998. And this guy, Bob Carter, didn't write a technical paper on this, but wrote an opinion piece in a newspaper, and this was the title of his opinion piece. Of everyone I've shown, this is the only guy that doesn't have a physical science degree. He does have a PhD, it's in paleontology, which is a perfectly acceptable, respectable field. But he basically said, he didn't make a prediction either, he just said global warming has stopped. And he didn't deny the reality of global warming. Obviously, global warming had happened since 1880, since it was predicted by 19th century physicists. But you can cast this into a prediction. If he really believed that it had stopped, he probably would assume that it will stay stopped. It's stopped, it's got to stay stopped. Maybe it'll go back. So I turned that into a prediction. And amazingly, his prediction of no global warming actually gives more warming than Gilbert Klass's 1955 global warming prediction. So the question is, we don't know what it's going to do in 2012. 2010, that's the last data point. 2011 isn't over yet. We don't know what the global mean surface temperature will be this year. But you can actually buy and sell prediction contracts on what the temperature will be in 2012. There's a trading outfit where you can basically place bets with other people who might have different opinions. It's in Dublin, and as an experiment, I asked them to set up a series of contracts of bets, and they're very much like futures markets, like pork bellies and everything else. You can actually try to make a prediction what you think, and you can make money if you're right. And so it's now being traded. I flipped this 90 degrees so that I can plot the results. And there's the predictions, and there's what the market says. So these are prices of contracts. So basically, if you think it's going to be more than a degree and a half above the 1880 temperature, you can buy a contract and you'll get money back if you win. And you can convert that to probability. So everybody says global warming is real. Nobody's buying contracts in the blue or selling contracts in the blue. So everybody agrees global warming that's happened since 1880 is real, and you can actually move the dots up and say, well, there's absolutely certain it's going to be warmer than the broker would have said if he had used Linsen's sensitivity. And it's probably going to be warmer than either Plass or said in 1955 or Carter said in 2006. And it could certainly be even as warm as 20% chance of it being warmer than Wally Broker said in 1975, which actually was considered to be a high sensitivity. So we can actually extract some idea of consensus, and these are people who are actually risking something. What is the consensus of people who are willing to risk something? And so I'm proposing this as a means of combining all these probability density functions, this broad array of functions that I showed, into one consensus function. So here it is. If you want to trade, here are the contracts. You can send your money to Dublin. They will open an account for you, and you can bet away. And if you disagree, if you're a denier, if you're certain that global warming isn't true, and you're right, you can make a lot of money. So I will close out with a couple of quotes. Robin Hanson he didn't invent prediction markets, but he's very much promoted them. He's an economist. He's actually an undergraduate of Caltech, but I understand he did his undergraduate in physics. And if you have questions, I highly recommend this site, skepticalscience.com, which addresses all the denialist arguments from a scientific perspective. Thank you.
Thank you, Mark. We're going to take a short break, about 15 minutes for refreshments, and we'll come back.